the graphing radical functions, we're going to start with square root, the square root function. Square root. And then we'll do cube root. Square root function. That's radical. So I'm going to give you the general form, and what you're going to, the big picture of this is actually really important, to be able to look at any equation and look at its form and know ahead of time, just by looking at it, what the shape is and, you know, kind of where it's located. You can tell that just by looking at the equation without even doing an XY table, if you really know what's going on, and it applies to all the different function families. So once you start to see the big picture, it's even more powerful. So this is the form for square root, right? Radical, square root, and this is what each thing means. But before I go into that, I want you to remember something that should remind you of this. And so this is, all right, recall. So this is for review. This is great review right here. In our earlier units on quadratic functions, the graph, of course, is a parabola for quadratic functions. And we had this form, y, I want you to compare, y equals a x minus h squared plus k. Okay, that was like all of the unit on quadratics was about that. And it's helpful to know where the parabola is before you start making a table, because what if it's shifted to the right 10 and up 20, and then you start plugging in for x 0, 1, 2, you wouldn't even see the graph. So you really need to know what's happening. So I'm just going to show you to review for you. Well, maybe I won't write it out, but if a was positive, what happens to the parabola? It opens up, and if a were negative, down, and if a were like a big number, absolute value were big, it would be skinny, and if a is like a fraction, like 1/10, then it would be fat or wide. I prefer wide. We don't be judgmental here. Okay, so, and then the HK determined where the vertex was. If it moved to the right, H would be positive, left negative, and K positive up, negative down, right? So all these have this form. It just varies a little bit, but you're going to be able to tell where every kind of graph is situated. It makes your life much easier when you're graphing it. So let me tell you what all these variables mean. There's the constants A, H, and K. There are three X and Y stay, but you know those are like the X and Y axis, but A, H, and K. So what do they mean? Okay, so the A, you can tell right ahead of time. So A, if it's negative, it will reflect the graph of the square root, reflect over the x-axis. If a is negative, it's like opening down. When the parabola, when a was negative, it opened down because it reflects over the x-axis. So like any point that was previously here will move down there. It reflects over the x-axis. If the absolute value of a is big, then it will stretch vertically, which makes it skinny. Well, in terms of the parabola, it makes it skinny. So stretch vertically, so it goes like that. It stretches it. You'll see some examples when we get there. If the absolute value of a is small, then it compresses it vertically. Compress vertically, and that makes things wide. So like that, it compresses it vertically. So A, just by looking at an equation, you can tell a lot about what your end result should be. And I haven't even given you the equation yet. And then of course H is going to tell you, just like before, it translates if it's positive, you will shift to the right. If it's negative, you will shift to the left, just like you would expect, and the same as for a parabola. And then K, just like you would expect, if K is positive, you move up, you translate up, and if it's negative, you'll shift the whole graph down. So that's the summary before I do examples. That's the formula, if you will. And you'll start to see how useful and powerful these things are. So let's say, let's do examples where we graph and state the domain and range. We'll do a few so you can see what's happening. Graph and state the domain and range. Domain and range. So for my first example, I want to do the most basic square root function, because this is like the, you know, the dancing math, all the different function families. You always start with the parent graph, like the most basic, and then we can shift it. We can translate it and stretch it and reflect it, but we need to know what that looks like. So I would hope for all of you that you can see a mental picture of what that is. And if not, then you just make a little XY table for yourself and you pick the easiest values you can. What do you know that X, what's the smallest value that X can have? Because we're only going to graph real numbers. So what's the smallest value we can put in here? 0. We can't get any smaller than 0 for the square root in the real number system. Okay? What's the next easiest value to pick for X? 1, because it's a perfect square. So what's the square root of 1? And the next easiest value? Not 2, because that would be an irrational number. 4. Okay, we're going to stop there. That's it. You really only need 3 points to graph these. So you would go like this. You would sketch for yourself. You go, okay, 0, 0, 1, 1, 4, 2. And that's the shape that you're familiar with. You should all kind of see that. And yes, it's related to x squared. It's the u basically opening to the right, and it's only the top half of the u. And so you want to automatically just be able to do that really off the top of your head. Okay, and now we'll do 2 examples of graphing this where it's, well, 3 maybe examples. So let's see what happens if we, I'm going to switch to a new board here. So let's say we do y equals negative 3 root x. Oh, and then we'll practice stating the domain and range as well. Okay, so before we even start, see how a is negative 3. That's going to do 2 things to the parent graph. What 2 things is it going to do? I'm going to describe it right here. Because in your homework, sometimes I won't even tell you to graph it. I'll just say describe what's happening. So what is this? What does the negative do? Reflect. So you would write reflect over x-axis. This is how I want you to do number 16 to 24 in your homework. Just describe the transformation. You reflect over the x-axis, and you, now what does the 3 do? You're stretching it because you're multiplying everything by 3. So that's like previously you might get 5, but now you're going to get 15. Any output you would normally get, you have to make it 3 times as big, so it stretches it vertically. And those are the 2 transformations. So you can still make your table to, okay, so what should I use for x? What should I put in? 0. Give me the easiest things that we used before. 1 and 4. Yeah, you should just know to go to perfect squares, because we can do it in our head. Square root of 0 times negative 3, 0. Square root of 1 times negative 3, negative 3. Square root of 4, 2 times negative 3, negative 6. Okay, so let's look at the effect this has. So we have 0, 0. We have 1, negative 3. And we have 4, negative 6. So do you see how it is stretching it, and it flipped it? So normally it went this way, and now it's going to go that way. Okay, so not only did it reflect over the x-axis, it stretched it vertically. And 3 points is plenty for sketching these radical functions. Domain and range. This is awesome practice for domain and range. Okay, look at the set of x values. Where does x go from? And when you go from right to left for the domain, this will be great review for x is, so do we think it's all real numbers? It goes all the way over here and all the way over here? What is x? Yeah, x is limited to be greater than equal to 0. Absolutely. You can't have a negative number for x under the radical. And then what about up and down for y? Does it go everywhere, all the way up and all the way down? Yes. Y less than equal to 0. And that would be the range for that. Let's try at least one more example, and then we will try it. We'll try it out. So let's try f. I'm going to write it a little bit different notation because just function notation. F of x equals 1/2 the square root of x minus 3 minus 1. Okay, so what effect does the half have? If you take a half of every output, compress vertically, good. Before I even know, I know it has the same shape. What about the x minus 3? What does that do? Is it right or left? 3. H is positive 3. If you compare this to y equals a root x minus h plus k, see how h is positive 3? So it's to the right 3. And what about up or down? K is negative 1. Down. Down 1. Okay, so what you can do is you can, well, we'll make a XY table, but I know the most important point, since it goes to the right 3 and down 1, is I'm going to want to plug 3 into this function. That helps me know what values to use. Since I know it shifted to the right 3, I'm going to plug 3 in here because you can see you get 0 under the radical. 0 times 1/2 minus 1 is negative 1. And do you see how the point 3 negative 1 means move to the right 3 and down 1? Alright. Okay, so the next easiest value to use probably is 4, because 4 minus 3 is just 1. Square root of 1 is 1/2. 1/2 minus 1 is negative 1/2. And what would the other easy value be to use? Can you tell me what else would make this a perfect square under here? I used 3 because I got 0. I used 4 because I got 1. Do you see I want to use 7? You want to make your life easy. 7 minus 3 is 4. Root is 2 times 1/2 is 1 minus 1 is 0. 4 is 2, 1 minus 1, yeah, 0. So I'm going to plot these now. So I have 3, negative 1, 4, negative 1/2, and by the time I get to 7, 1, 2, 3, 4, these should be evenly spaced, 5, 6, 7, 0. So it has the same kind of shape, but it's compressed, and the starting point is right there, and it's compressed vertically. So let's state the domain and range, and then we'll be done. For x, the domain, what is x? Where does it start, and then what does it go to? X goes from greater than equal to 3. Nice. And the range for y is, what's the smallest value that y can have? Greater than equal to negative 1. Yes, because it goes from -1 up from there. Excellent.